For centuries, humanity asked the same question: is Earth the only world where life can exist? For most of human history, there was no way to answer it. The stars were too distant, the planets were invisible, and the possibility of another Earth remained nothing more than speculation. Then astronomers began finding planets around other stars. Hundreds, then thousands. But finding another planet was only the beginning. The real challenge was finding one in the right place. Not too close to its star, not too far away. A region where temperatures could, under the right atmospheric conditions, allow liquid water to exist. Astronomers call this the habitable zone. And in 2011, NASA's Kepler mission found something extraordinary: a planet orbiting a star remarkably similar to our Sun, inside that potentially habitable region. Its name was Kepler 22b. It was the first planet confirmed by the Kepler mission to orbit within the habitable zone of a Sun-like star. Suddenly, the search for another Earth felt different, because Kepler 22b wasn't merely another distant planet. It was a world occupying one of the most interesting locations astronomers could find. But there was a problem. The more scientists learned about Kepler 22b, the less certain its resemblance to Earth became. It is larger than our planet. Its mass is greater. And scientists still don't know whether its surface is rocky, covered by a deep ocean, or hidden beneath a thick atmosphere. So what exactly is Kepler 22b? A potentially habitable world? A water-rich planet? A miniature Neptune? Or something completely different? To answer that, we need to travel nearly 600 light-years away, toward the constellation Cygnus, because there, a planet was waiting to challenge our definition of an Earth-like world. Kepler 22b orbits a star known as Kepler 22. The star is somewhat smaller and cooler than the Sun, but similar enough that astronomers consider its planetary system an especially interesting target in the search for potentially habitable worlds. The planet itself travels around its star at a distance of roughly 0.8 astronomical units. That means its orbit is somewhat closer to its star than Earth's orbit is to the Sun. And yet, the planet receives an amount of energy that places it within the star's habitable zone. Its orbital period is approximately 290 Earth days. So if someone stood on Kepler 22b, assuming the planet has a surface and an atmosphere suitable for an observer, a year would pass in less time than it does on Earth. But the number that made Kepler 22b famous wasn't its year, it was its location. The habitable zone is often called the Goldilocks zone. The idea is simple. A planet too close to its star may become too hot for liquid water to remain on its surface. A planet too far away may become too cold, allowing water to freeze. Between those extremes, there can be a region where temperatures could theoretically allow liquid water. But there is an important distinction. Being inside the habitable zone does not mean a planet is habitable. It only means the distance from its star is potentially suitable. Atmosphere matters. Pressure matters. Clouds matter. The planet's composition matters. And perhaps most importantly, we need to know what the planet actually looks like beneath all of those unknowns. Kepler 22b is about 2.1 times Earth's radius. That immediately places it in a different category. It is classified as a super-Earth, but the name can be misleading. Super-Earth doesn't mean a larger version of Earth. It simply describes a planet larger than Earth, but smaller than the ice giants in our solar system. A super-Earth could potentially be rocky. It could possess a deep atmosphere. It could have a global ocean. Or it could be something that doesn't resemble Earth at all. Kepler 22b is a perfect example of this uncertainty. Its estimated mass is around 9.1 times Earth's mass, according to NASA's current Exoplanet catalog. That gives us an important clue, but not a complete answer. Planetary composition cannot always be determined simply from mass and radius. Two planets with similar sizes can have radically different interiors. One could contain a large rocky core surrounded by a relatively thin atmosphere. Another could contain enormous amounts of water and a thick volatile envelope. A third could have a substantial hydrogen-helium atmosphere. From Earth, all of these possibilities can appear surprisingly similar, and that's exactly what makes Kepler 22b so interesting. when Kepler discovered the planet. It didn't photograph Kepler 22b as a detailed world. Instead, the spacecraft watched the star. Kepler was designed to detect tiny changes in a star's brightness. When a planet passes between the telescope and its star, the planet blocks a tiny fraction of the starlight. The star becomes slightly dimmer. Then, as the planet moves across the stellar disk, the brightness returns to normal. This is called the transit method. The change may be incredibly small, but if it repeats at regular intervals, astronomers can identify a planet. From the depth of the transit, they can estimate the planet's size. From the timing between transits, they can determine its orbital period. And from the behavior of the system, they can begin reconstructing the architecture of a world that cannot be directly photographed. That is how Kepler 22b first appeared to humanity, not as an image, not as a landscape, but as a tiny dip in the light of a distant star. A barely noticeable reduction in brightness, repeated again and again and again. Hidden inside that pattern was a planet, a world roughly 600 light years away, a world that had probably been orbiting its star for billions of years, completely unaware that one day, its existence would change the way humans search for life beyond Earth. The discovery was important for another reason. Before Kepler 22b, astronomers had already found planets in habitable zones. But Kepler 22b became the first planet confirmed by the Kepler mission in the habitable zone of a star similar to our Sun. That distinction mattered. The search for Earth-like planets wasn't simply about finding planets at the right distance. It was about understanding whether planetary systems like ours were common, and Kepler 22b became an early demonstration that potentially interesting worlds could exist around stars resembling our own. The implications were enormous. If one such planet existed, how many others might be waiting in the darkness? But there was something else about Kepler 22b that made the discovery more complicated. The planet is significantly larger than Earth. That means its gravity would also be stronger. Its environment could be completely different. A person standing on its surface, if a solid surface exists, would experience conditions unlike anything on Earth. And that leads to one of the biggest unanswered questions. Does Kepler 22b even have a surface? We know its radius. We have an estimate of its mass. We know its orbit. We know the type of star it circles. But those measurements don't tell us exactly where the planet's atmosphere ends and where its interior begins. A thick atmosphere could extend high above the planet. A deep ocean could cover much of its surface. A rocky interior could sit beneath hundreds or even thousands of kilometers of water and high-pressure ice. Or the planet could have an entirely different structure. NASA has noted that scientists have not yet determined whether Kepler 22b is predominantly rocky, gaseous, or liquid. That uncertainty is not a weakness of the discovery. It is the reason Kepler 22b remains scientifically interesting. There is also another misconception worth clearing up. Kepler 22b is often described as an Earth-like planet, but that phrase can mean several different things. Earth-like in size? No, it is much larger. Earth-like in temperature? We don't know. Earth-like in atmosphere? Unknown. Earth-like in composition? Unknown. Earth-like in its potential for life? Still unknown. The strongest similarity is its position within the habitable zone of a sun-like star, and that alone is not enough to call it another Earth. This distinction is critical when searching for life. Astronomers aren't simply looking for planets at a particular distance. They are looking for a combination of conditions. A planet needs an appropriate energy source. It needs the right physical environment. It may need a stable atmosphere. It may need liquid water. And it needs enough time for chemistry to develop into something more complex. Kepler 22b checks only some of those boxes. The rest remain open questions. And then there is the question of water. Could Kepler 22b be an ocean world? It is one of the possibilities scientists have considered. A planet with a substantial water inventory could look very different from Earth. At sufficient pressure, water doesn't behave like the oceans we know. Deep inside a massive water-rich planet, extreme pressure can produce exotic forms of ice. The surface could therefore be separated from the rocky interior by enormous layers of high-pressure material. Such a world could have oceans, but they might exist in a planetary environment, unlike anything in our solar system. There's another possibility. Kepler 22b could possess a thick atmosphere that traps heat. The habitable zone assumes certain atmospheric conditions. Change the atmosphere, and the climate can change dramatically. Venus demonstrates this in our own solar system. Earth and Venus are relatively similar in size, but their atmospheres produce radically different surface environments. So simply placing a planet at the right distance from a star tells us very little about what it feels like on the surface. Kepler 22b could be receiving the right amount of energy while still being completely inhospitable. That is the central mystery. Kepler 22b sits in the right neighborhood, but we don't yet know what kind of house it is. And the farther astronomers look into its properties, the more important that distinction becomes. Because Kepler 22b isn't valuable simply because it might contain life. It's valuable because it helps scientists understand how many different types of planets can exist in the habitable zones of sun-like stars. And that brings us to the most important question. If Kepler 22b isn't necessarily another Earth, then what is it? A super-Earth? An ocean world? A planet wrapped in a massive atmosphere? Or something that doesn't fit neatly into any category we currently have? The answer may depend on what is happening beneath its atmosphere, and whether future observations can finally reveal the chemistry of this distant world. Kepler 22b became famous because of where it is, but location alone doesn't tell us what the planet is. And this is where the story becomes much more complicated. The planet is more than twice Earth's radius, and NASA currently lists its mass at about 9.1 times that of Earth. Those numbers immediately tell us something. Kepler 22b is not simply a larger version of our planet. It belongs to a category of worlds called super-Earths. And super-Earths can be incredibly different from one another. Earth has a rocky surface beneath a relatively thin atmosphere, but Kepler 22b can have a very different structure. Scientists still don't know whether it is primarily rocky, gaseous, or rich in liquid and other volatile materials. One possibility is that Kepler 22b could be a water-rich world. If so, its oceans might be far deeper than anything on Earth. Pressure would increase dramatically with depth. Eventually, water could exist in high-pressure forms of ice that don't naturally occur at Earth's surface. In that scenario, Kepler 22b might contain enormous amounts of water while still looking nothing like Earth. But there is another possibility. The planet could possess a thick atmosphere, and that changes everything. The habitable zone is based primarily on how much energy a planet receives from its star, but a planet's atmosphere determines how that energy is distributed and retained. A thick atmosphere can trap heat. Clouds can alter the amount of energy reflected back into space. Atmospheric composition can completely transform the surface environment. Venus demonstrates just how powerful this effect can be. It is roughly similar to Earth in size, yet its surface is an extreme environment because of its dense atmosphere and powerful greenhouse effect. So even if Kepler 22b receives a potentially suitable amount of energy, its surface could still be nothing like Earth's. And that creates a crucial distinction. Kepler 22b is potentially habitable by location. That does not mean it is actually habitable. Astronomers need much more information. They need to understand its atmosphere, its composition, its temperature structure, and ideally, whether water is actually present. That is where future observations become extremely important. The problem is distance. Kepler 22b is hundreds of light years away. Astronomers cannot simply point a telescope at it and see continents, oceans, or clouds. Instead, they have to extract information from the tiny amount of light that reaches Earth. When the planet passes in front of its star, some starlight passes through the planet's atmosphere before reaching our telescopes. Different molecules absorb different wavelengths. By carefully measuring those changes, astronomers can potentially determine what gases exist around the planet. This technique is called transmission spectroscopy. It is one of the most powerful tools available for studying distant exoplanet atmospheres. But Kepler 22b is a difficult target. Its atmosphere has not been characterized well enough for scientists to confidently identify it as an Earth-like world. And that uncertainty is actually more interesting than a simple answer would be, because Kepler 22b forces astronomers to confront a much larger question. How many planets in the habitable zone are actually habitable? We don't know yet, and that is one of the biggest questions in modern exoplanet science. There's also something remarkable about its orbit. Kepler 22b completes one revolution around its star in about 289.9 days. That makes its orbital period surprisingly familiar. Earth takes about 365 days. Kepler 22b takes about 290. But this similarity doesn't mean the two planets experience similar years. The length of a year tells us only how quickly a planet orbits its star. It doesn't tell us the temperature, the atmosphere, the surface, or whether life exists. Two planets can have similar orbital periods and completely different environments. So why did Kepler 22b become such an important discovery? Because in 2011, it demonstrated something scientists desperately wanted to confirm. A planet could exist within the habitable zone of a sun-like star. That discovery changed the search. The question was no longer simply, are there planets around other stars? We already knew the answer. The question became, how many of those planets occupy environments where life could potentially exist? Kepler 22b became one of the early worlds that helped move astronomy toward that question. But there is still one mystery that matters more than all the others. What is beneath those clouds? If Kepler 22b is a rocky planet with an atmosphere, its environment could potentially be very different from Earth's. If it is a water-rich world, it could be an enormous ocean planet. If it has a thick gaseous envelope, its surface might be buried beneath pressures and temperatures completely hostile to life as we know it. And if the planet has no solid surface at all, then calling it another Earth would be completely misleading. Right now, astronomers cannot confidently choose between these possibilities. And perhaps that's what makes Kepler 22b so compelling. The planet was discovered more than a decade ago. We know where it is. We know its orbit. We know its approximate size. We know its mass estimate. We know that it receives the right general amount of stellar energy to place it within the habitable zone. But the most important question remains unanswered. What kind of world is it? That answer could determine whether Kepler 22b belongs in the conversation about potentially habitable planets, or whether it was simply one of the first reminders that the universe can place very different worlds in very similar locations. And to find out, astronomers will have to keep looking at the light coming from a planet they may never see directly. The most exciting thing about Kepler 22b may not be what astronomers have discovered. It may be what they still haven't discovered, because after more than a decade, we still don't know what the surface of this planet looks like, and that uncertainty leads to a much bigger question. Could Kepler 22b actually support life? The honest answer is, we don't know. The planet has one important advantage, its location. Kepler 22b receives stellar energy within a range that places it in the habitable zone. But habitability requires much more than sunlight. Earth's ability to support life depends on a complicated combination of atmosphere, temperature, liquid water, chemistry, and long-term stability. Kepler 22b has not yet been shown to possess that combination. And this is where the story becomes important, because astronomers aren't simply searching for another Earth. They're trying to understand how Earth-like conditions actually emerge. Kepler 22b could help answer that question. If it turns out to be a water-rich world, then it would demonstrate that planets substantially larger than Earth can maintain enormous reservoirs of water while orbiting within a habitable zone. If it has a thick atmosphere, scientists could study how atmospheric composition changes the climate of a super-Earth. And if it turns out to be predominantly rocky, that would make the planet even more interesting. Each possibility tells us something different about planetary evolution. There's also the question of life beneath the surface. On Earth, Life isn't restricted to the places receiving sunlight. Microorganisms exist deep underground. Life survives around hydrothermal vents. Extremophiles occupy environments once thought impossible. So even if Kepler 22b doesn't look like Earth on the surface, that doesn't automatically eliminate every possibility for biology. But there is an important limit. Without evidence of an atmosphere, liquid water, or a suitable chemical environment, there's currently no scientific basis for claiming that Kepler 22b contains life. The planet is potentially habitable. It is not a confirmed inhabited world. That distinction matters. And this is why the search for biosignatures is so important. A biosignature is a chemical or physical feature that could indicate biological activity. On an exoplanet, astronomers might look for combinations of gases that are difficult to maintain through non-biological processes. Oxygen is one example. Methane is another. But detecting a single gas would not be enough. A convincing biosignature would require context. Scientists would need to understand the planet's atmosphere, chemistry, star, and possible non-biological explanations. The goal isn't simply to find an interesting molecule. It's to determine whether biology is the most reasonable explanation. Kepler 22b is currently difficult to study at that level. Its distance makes detailed atmospheric observations challenging, and its large size adds another complication. The planet is not a straightforward Earth analog. That means astronomers cannot simply assume its atmosphere behaves like Earth's. Instead, they have to work with limited measurements and increasingly sophisticated models. This is one reason why exoplanet science often moves slowly. A discovery can happen in a single announcement. Understanding the planet can take decades. And Kepler 22b has already demonstrated that. When it was announced in 2011, the discovery immediately attracted enormous attention. It was the first planet confirmed by the Kepler mission in the habitable zone of a sun-like star. At the time, it represented a major step toward finding potentially habitable worlds. But more than a decade later, the planet remains mysterious. The discovery gave astronomers a location. It didn't give them a complete world. That distinction is important because the word Earth-like can create the wrong impression. Kepler 22b isn't another Earth. It is larger. Its internal structure is unknown. Its atmosphere is unknown. Its surface conditions are unknown. And there is no confirmed evidence of life. What makes it special is something more precise. It is a super-Earth orbiting within the habitable zone of a sun-like star. That alone makes it scientifically valuable. And Kepler 22b is part of a much larger story. The Kepler mission changed astronomy by demonstrating that planets are incredibly common. The galaxy contains billions of stars. Many of those stars have planets. Some planets are small. Some are enormous. Some orbit extremely close to their stars. Others travel much farther away. And among that enormous population, some occupy regions where liquid water could potentially exist. Kepler 22b was one of the early discoveries that helped reveal just how interesting that population could be. The real significance of Kepler 22b may therefore have little to do with whether it becomes humanity's next candidate for a second Earth. Its importance is that it helped change the question. Before thousands of exoplanets were discovered, Earth seemed unique. Today, Earth is still the only world known to support life. But it is no longer obvious that planets capable of supporting life should be rare. There may be billions of potentially interesting worlds scattered throughout the galaxy. We simply don't know which ones actually cross the line from chemistry to biology. And that brings us back to Kepler 22b, somewhere nearly 600 light-years away. A planet continues its orbit every roughly 290 days. It completes another journey around its star. The planet doesn't know that Earth exists. It doesn't know that humans have detected its shadow crossing the face of its star. And it certainly doesn't know that scientists are debating whether it could contain oceans, clouds, an atmosphere, or perhaps something entirely unexpected. But its light has reached us, and that is enough to begin the investigation. One day, more powerful instruments may tell us more. Future observations could constrain the planet's atmosphere. Better measurements could improve our understanding of its mass and internal structure. And as astronomers study more planets like Kepler 22b, they may eventually learn which combinations of size, atmosphere, and stellar environment are most favorable for life. Perhaps Kepler 22b will turn out to be a barren world. Perhaps it will be an ocean planet. Perhaps its atmosphere will reveal something unexpected. Or perhaps it will remain one of those distant worlds that raises more questions than answers. Any of those outcomes would be scientifically valuable. Because the search for life isn't about finding a planet that looks exactly like Earth. It's about discovering how nature creates habitable environments, and whether biology appears whenever the conditions are right. Kepler 22b is one piece of that enormous puzzle. Not proof of alien life, not a second Earth, but a world in the right cosmic neighborhood, waiting for us to understand what it really is. For now, Kepler 22b remains hidden behind distance. We cannot see its oceans. We cannot stand beneath its clouds. We cannot look across its horizon. All we have is starlight and the tiny changes contained within it. But sometimes that is enough, because a planet doesn't have to be close to change our understanding of the universe. It only has to be there. Kepler 22b is there, a distant super-Earth, a world in the habitable zone. And one more reminder that Earth may not be the only place where the universe has created the right ingredients for something extraordinary. The question is no longer whether other worlds exist. They do. The question is, what are they hiding?